Good morning. Hey, Lindsay, how are you? I'm doing well. I just started the live stream. This is kind of surreal. I know. I'm excited. It's gonna be fun. I I took the time and modeled the project this morning. Kind of went through my notes and stuff, and so instead of hitting the calculate button, we talked about it kind of stalls out um, the program. I have another screen, another window of EnergyPro all queued up with it all done. So all I have to do. So what I'll say is I'll go to the over the shoulder view and say, all right, why this is calculating? What do you guys think? Is it going to comply? Not comply? Let's take some bets here, and then I'll bring up the other version of EnergyPro with it already done, and then I'll hit the print button. It'll have the results and all that stuff. So, and nobody will be the wiser. Yeah. So I'm just making sure all my chat windows are good. Did the okay. Oh, I'm so sorry. Is he okay? What happened? Oh, oh, yeah. Oh, that's so hard, and it's just a nasty trick on people to make them diabetic. That's just horrible. They. Oh, yeah. Yeah, of course. Yeah, good. Glad you took responsibility for that. Yeah, I'm so sorry. Well, um, I know, right? Gosh, that's a lot of pressure. So, huh. Says stream health is live. It's been streaming for 3 minutes. There's 2 people watching. Yeah, Zach's probably out there watching already. Uh, yes, that's correct. Oops. Let me drag this. I'm trying to arrange all my monitors and stuff so that I don't get things popping up wrong, right in the middle of the page that I'm viewing live. So yeah, it should be ready to go. There's Zach. Zach's there. I don't know yet. Morning, Zach. How's it going? So Lindsay's having a hard time seeing the live stream link. Try closing YouTube and opening it again. Yeah. Okay. Can you send it to Lindsay? That way she can just click on the link. It'll take her right there. select a monitor, see how many people. It still says just 2 watching, so. Oh, 3 watching now. We have a visitor. Yay. Maybe it's Jill or Betsy or Lisa, or if one of you is watching, hit us up in the chat window and say hi. Of course, the delay, right? But there is no delay. If they're hearing it, it's not a delay for them. It's only a delay for me. Yeah, this will be a new... Good. Right on. Good morning, Jill. Jill, if you can hear my voice, let me know how the sound is and how the quality is. A little sound check feedback. You can type in the chat window. So I've updated the title and the description, so we can go back in and tweak it later. So I'm not too worried about it. I just kind of put some general information in there. Did we ever figure out that chat issue? Like how to get that chat window to pop up? Jill just texted me. She says, I don't know how to chat. Right. I just... Oh. So that is it. You have to create the channel. It looks like she logged. Yeah, I think she logged out. So I'll let people know during the... and there's no consequence to creating a channel. It doesn't mean that you're going to be broadcasting. You just have to create a channel. Is there an easy step to do that? So you got into the live stream then? That link worked? Good. Man, I need a 4th monitor. First world problems, right? Good. Well, it sure would be nice to get this chat feature to work better. You know what I mean? Oh, click on that little account thing, basically. Yeah. Jill says, "Arg." Oh, good. Good. Sure. Okay. Yeah. Oh, do they actually see the chat if they don't have chat capability? They just can't type it in. Gotcha. Oh, that's true. They'll see it right on the screen. Duh. That's pretty funny. Well, good. We have 5 people watching. Woo! All right, I see the numbers growing. So thank you for tuning in to our first episode of Code and Coffee. So um, now 6 people. Good. Well, take a minute and take a look at our brought to you by introduction screen there. We'll begin our live broadcast right at 10 a.m. So stand by there. And if you have any questions, please hit us up in the chat window. Lindsay's currently typing some instructions for those of you who are having trouble getting into the chat feature. You may have to create a channel in order to do that. Oh, good morning, Chandra. Welcome. Glad you could make it. We should have quite a few people here today. So, we're in the range of 20 plus, so we'll see who shows up. I'm pretty excited about this. So, all of you out there watching and have chat features, you can point out all my mistakes that I make when I'm modeling. There's a lot of pressure here, doing this live and you guys looking over my shoulder. So, pretty excited about it though. Lindsay's putting some instructions up in the chat window for those of you who have not been able to enable your chat feature. You can take a look at Lindsay's instructions there. You need to create a channel. There's no impact on your account if you create a channel. It doesn't mean that you have to, film a, something. It just means that you have that capability to chat. So you can see there, to create a channel, click on your avatar. That's kind of your account picture there. It might be blank if you haven't set that up yet. No big deal. On the far left, click the Creator Studio button and then click the Create Channel button. And she says it's to the far right, not to the far left. So should be in the upper right hand corner. So thank you for correcting that, Lindsay. Good. We've got 8 people watching already. Good. Welcome, everybody. First episode of Code and Coffee. We'll have some video streaming here in just a few minutes. So this is kind of our welcome screen. So we have some information up there. Obviously, this episode, this channel is brought to you by EnergyCode Ace. So all of the Codes and Standards team, we thank you so much for sponsoring this and giving us the opportunity to bring this live stream video to you. So for those of you who may be watching this as a recorded message, you probably won't see this part. We'll probably edit this out. But anyways, we'll begin here shortly. So if anybody had any questions, you're welcome to type those in the chat window. I'll be responding to chat questions throughout today's episode. So we have some other courses available to you. We're highlighting our Title 24 Part 6 Essentials non-residential and residential modeling courses there. You can find those on the EnergyCode Ace website. Click on the training tab. You'll see our banner scrolling across the bottom here, kind of highlighting all the fun things that we do at EnergyCode Ace. So for those of you tuning in here, this is our first episode pilot. You guys were invited by myself or somebody else to participate in this pilot episode. So hopefully this will all go off without a hitch, but it is a pilot episode, so we may have some technical difficulties. So hopefully everybody got the email from EnergyCode Ace this morning about the link to the live stream. So if you just clicked the link through the previous email that went out, obviously you're here, so glad it worked. Good. Nobody's using the chat window. I was hoping people would be like giving me a bad time and typing funny things and making me laugh on camera and all that. So we're up to 10 watching now, so we got about 5 more minutes before we begin our live broadcast. The email this morning worked great. Oh, good, Chandra. Glad. Yeah, we thought of that kind of late in our program here, and Zach, one of our tech team members, came up with that idea. Hey, let me email this out. So, oh, good. Adrian's on. Good morning, Adrian. Glad that you could make it. And good. I'm glad the instructions for getting your chat working worked out for you. So, good. Chandra says we don't want to haze you this early in the process. Well, that's funny. This is code and coffee. I'm on my third cup already, so I'm doing pretty well. So bring it on. All right, we're up to 12 watching already. We got about 5 minutes or so before we start our broadcast. So anybody have any questions about? Yes. Oh, okay. Mm-hmm. Yep. Okay, so for those of you wondering what I'm talking about, I've got one of our tech team members in my ear telling me how to make somebody a moderator. So, um, where do I approved users? Yeah, I'm not sure quite how to. Yeah, not quite sure how to do that. So, yeah, that's a good idea. Good. All right, up to 11 viewers. That's awesome. Kind of exciting. We started this live stream early this morning to kind of work out the bugs here. So if you see our elapsed time is 17 minutes, you haven't missed anything. We're just taking this time to set up our channel and make sure everything's working right. So if somebody were to click back on this after the recording is done, we're going to edit this part out. So we'll probably start like a minute or so right before the live stream. So we got 3 more minutes. You guys hang in there. Thank you so much for tuning in. We would love to get your feedback on this. So when all's said and done, we'll probably hit you up with an email, and it'd be great to get some comments back from everybody on what they thought of the episode. Is there anything we can do to improve it? How was the sound? How was the video quality? Did you have trouble logging in? Did you have trouble chatting? Things like that. So we'll put something together and ask you guys some questions and hopefully get some good feedback. We don't necessarily have a schedule for the next episode, although I've got about 1 million ideas for episodes. So this is the pilot. We want to see how well it works and what we need to do to, if we need to tweak anything, make it better, we'll need to do that. And then we're going to come out with a schedule of these. They will all be on Friday mornings at 10 o'clock, so from 10 to 11. So for those of you that might want to set a reminder in your calendar to check it out. If you subscribe or like and subscribe to the Energy Code Ace YouTube channel, I believe you'll get a message saying that Energy Code Ace has a live stream video going. So Adrian says, I have a question for you, Brian, maybe off topic, but I have a project with 2 single family houses built back in '07 and never completed. So that's a good question. So Adrian has some information about it. So the walls are 2x4, windows, sliding, and roofs existing, no insulation. So one question, did they maintain a current building permit? If they maintained a current building permit, meaning that they got regular inspections, they did some work, and they have the old building permit's current, then that still falls under the older code. So what was that, 2005 code? You could probably get it comply easily there. If they let it lapse, unfortunately, really falls down to the building department's mercy. So technically, they should hold you to the 2016 standards, and there's going to be a lot of work they're going to have to do to make up for that. So because it was never final, you couldn't do an E plus A plus A. So yeah, that's a good question, Adrian. Though I like that. All right, it is 10 a.m. So I'd like to take a second to welcome everybody to the first episode of Code and Coffee. This episode is, and all episodes in the future are brought to you by EnergyPro Ace. So thank you, EnergyPro Ace, for sponsoring us. I'm going to take us to our, before I take you to our introduction screen where I'm going to introduce our project, just want to point out a couple things. We do have some courses that we're highlighting today. You'll see that the Title 24 Part 6 Essentials non-residential and residential modeling courses are coming up real soon. So you can go to the energycodeace.com site or click the link in the description below, and that can take you right to the EnergyPro Ace site. So great. Michelle Plotnick's on. Good. Lindsay, Adrian, Chandra, some of you others that are watching may or may not have the ability to use your chat yet. Lindsay posted some instructions up in the chat window, so you can follow those instructions. You have to create a channel first, and you can do that by clicking your little avatar up in the right-hand corner. So, all right, without further ado, let's take a look at our project, and of course we've got our live stream video. So, hello everybody. My name is Brian Selby. I'm your host of Code and Coffee. I'm really excited about this project here, and hopefully we can shed some light on some very simple modeling techniques. Our project today is a simple single-family home. It's in climate zone 12. This happens to be a real project, so we're not making stuff up. We're not like, making some fictitious project. This is one of my clients up in the Sonora area. Some of you know I was born and raised. I lived most of my life in Sonora. I live in Lincoln, California now. So our project, we get some specifications here. I'll be showing you some of my notes and how I do my takeoffs, but we got some information from the client that, they, kind of given me some guidance. We don't have anything set in stone yet for this project, but we know that it's located in climate zone 12. The attic roof insulation, they want to incorporate that below roof deck insulation, so we'll be modeling that. Client doesn't want to do the hyperpermeable walls. They don't want continuous insulation on the exterior walls. So we're going to give that a try, see if we can get it to comply. They are incorporating a high efficiency furnace, but a standard or minimum efficiency air conditioner. So it is a split system furnace, air conditioner. We'll take a look at the plans here in a second. And they are using a high efficiency tankless water heater. So we got some pluses, some minuses there. So we'll see how that works out with the performance approach. The software I'll be using today, I'm going to be using Bluebeam Review. You can see the revision or the version there that I'm using. It is a paid piece of software. You can download a free version of it to trial, but it's relatively inexpensive. I think I paid like $300 for it. Very powerful software. So you'll see once I dive into this. So we're also using EnergyPro version 7.1.3. I know it's going to be updated very soon, but it hasn't yet. So those are our applications we'll be using today. Some information about me, but we'll move on here. I want to introduce our project to you. So you can see here, here is a set of plans that was sent to me by my client, and he may even be on the phone right now. Rob Keith, real good friend of mine. I've known him for years. We actually grew up in the same neighborhood. So hello, Rob, if you're on the line. This is a project. You can see it's an estate-sized lot. We've got our house orientation. We've got a north arrow on here. We got some project information on the plot plan. Just kind of breeze through these plans here. It's a single-story house with an attached garage. So we are going to be modeling the house and the garage in EnergyPro. We've got a lot of information here. Rob incorporates my energy feature summary that I put together. So I'll be sharing that in future episodes, how I put those together for clients. So it might be helpful for you. So elevations. I like to just take a quick glance at these elevations to see if there are any windows or any features of this house that might need to be modeled. So I see we have some overhangs here. Probably not going to model overhangs today because of our time frame, but maybe in a future episode we can jump back into this and model some overhangs. Let's see, we got looks like shear wall plan. Sections might be very important. Looks like we've got a 9-foot plate, slab on grade, R38 ceiling insulation, R18 roof deck insulation. Most likely that's a below roof deck insulation. Looks like we have some vaults, a very shallow vaulted ceiling, a scissor truss. So we still talking attic trusses, no raised heel trusses. Our little porch overhang drops a foot. So yeah, little neat features here in this plan. Foundation plan, probably won't be referencing much. Roof framing plan, we might take a peek at that. And electrical plan. So this is a preliminary set. We don't necessarily have all the information, but I think we have enough here to get started. So let's dive in. First thing I always do is check our building orientation. So north arrow is facing up on our plan. So if you're not familiar with Bluebeam, I like to use the angle measuring tool. Very helpful. Here's how I do it. The vector created PDFs, Bluebeam snaps to the endpoints, so you can see how that works. And if I hold the shift key down, it'll hold me in different orientations here. So I'm just going to click straight up because that's north, and it looks like our front is facing 143 degrees, so kind of southeast. So I'm going to go here to my over the shoulder view. You can kind of get a look at my desktop here. So no mystery, this is where I work day in, day out, and you know, I'm taking some notes here. I'm writing 143 degrees. I use a quad paper format, so you can see once I start putting this together, you can see how my takeoffs come together, and it makes it easy for me. You may have a different process that works for you. You may note it on the plans for future reference, but this is how I do it. Hopefully we'll get good results at the end. So I got my front orientation. I go clockwise, starting from the front, left, back, right, and then you know, I'm going to come in here and just, you know, do my 4 orientations just to make sure that I'm on 143. Add 90 to that. My left orientation is 233, 93, 23 in the back, and add 90 to that, subtract 360, gives me 53 degrees on the right. So those are my orientations. I don't want to get lost. I always put them in a real simple format on my sheet here. It keeps my brain organized. So now I've got my orientation. I know I'm climate zone 12. Usually at this point I collect some project information like address, client name. We're going to call this, for the sake of illustration purposes, ECA episode 1. That is a EnergyPro Ace. Could call it Code and Coffee episode 1, right? All right, let's jump into our plan here. Typically what I do is I'm going to identify my zones. I've got 2 zones in this model. I've got a condition zone and I have an unconditioned zone. That's the garage. So very simple model here. First thing I want to do though is I'm going to calibrate the software here to make sure that my dimensions are right. Usually I check the longest dimension. That's going to give me the most accurate reading. So I'm going to calibrate that. The dimension said 78 feet. So I'm going to type in 78 feet. And then I'll go through and I'll verify that by measuring a short length of dimension that I know. So just to make sure, yep, my calibration's right, I'm good to go. So let me jump back to my Bluebeam screen so you can actually see what I'm doing here. So our floor plan, I'm going to start with my area. I'm going to calculate the area. I have a habit always starting in the lower left hand corner. That's just me. You may start in a different position, but I always know if I start on the same point. So those of you watching here who just tuned in, I'm using Bluebeam review software. I'm using the area tool. And then, we're just going to work our way around the building. The nice thing about Bluebeam is it snaps to these endpoints, and it gives me a really, really accurate area. So I always like to compare this to what the designer did. I don't always take the designer's area as being correct, because sometimes software, in this case, you see here the thickness of this wall between the house and the garage. The software may have chosen the inside of the wall, and we know that for conditioned floor area, it's the outside of that wall, because the wall itself is part of the conditioned floor area. So if I hold the shift key down, that allows the line to stay in ortho view, so it goes straight. So I'm going to close this boundary here, see what our area is. I get 1,638 square feet. I'm going to write that up on my takeoff page, 1,638 for the house. I like to do something kind of unique here. Is I like to highlight that, just color code it. So I go in here and I select a fill color. I use blue. I change the opacity to 20%, and we get a nice blue background on that. So let's go through and do the takeoff for the garage. I'm going to click the area tool. Lindsay, do I have any questions coming up? Anybody in the chat window hitting me up yet? Okay, good. For those of you watching on the live stream, I've got Lindsay and Zach, my tech team, on my headset here. So they're talking into my ears, trying to make me laugh and throw me off and challenge me today. So I'm just making my way around the garage here. You can see that most of these endpoints are snapping. Makes it really convenient for me. So to close the area, I just double click, and now I have my boundary. For me, I like to color code garages green for garage. That's my go-to. Fill opacity 20%. Good. Garage is 774 square feet. One other thing I like to do while I'm here, if you remember from our quick review of these set of plans, this is a slab on grade set of plans here. So we need a perimeter distance, and that's the edge of the slab. So I'm going to come in here and do a perimeter length. Now, if we had a CAD drawing, I probably would have opened this in like AutoCAD or one of the other CAD software programs and just drew a polyline around this and listed the polyline, but Bluebeam doesn't have that capability to list the length of your area box, so we have to go through and kind of do it again. So I'm not as careful when I do the perimeter. Usually I'm rounding off to the nearest foot, so you can see my perimeter length is growing as I make my way around. So you notice I didn't do the area or the perimeter adjacent to the garage because there's no slab edge there. There might be a slight step down in this, but we can see our perimeter is 165 feet, so I was actually pretty darn close. And that's lineal footage. You'll see when I input this into EnergyPro, I'll do a little over-the-shoulder view here and let you see how my takeoffs are coming together. So looks like Adrian had a question. Let's see if I can get to it here. If you look at oh, nice. Thanks, Adrian. I appreciate that. That is a nice little helpful tool there. Good. Well, I've got that. We could just add up these for the garage real quick. So we know the back wall is 12 feet. The side wall and front wall are 28. And this little return wall are 21. So we have 89 lineal feet. So doing it the old-fashioned way, right? So good. I've got my zone area takeoffs. I'm ready to get into doing my wall takeoffs. So I always start at the front of the house. I work my way clockwise. I'm going to start with the condition zone first. in EnergyPro, you have to insert your condition zone first, then your unconditioned zone. So we'll take a look at that separately. So I'm just going to go by my dimensions here. I've got 50 feet along this front wall. 50 feet. Our plate height is 9 feet. 450 square feet. I'm going to work my way around to the left. Our sidewall dimensions are, what is that, 28 feet overall. And that's 9 feet high, so 252 square feet. Our back wall is a little bit longer than our front wall because it's not overlapping in the garage. So I've got 66 feet, right? So 594, and working our way back to the right, we've got 19 feet along this right-hand wall, and that's times 21 feet. Sorry, I forgot the little 2-foot offset on the back. So 21 times 9 is 189 square feet. So at this point, I like to do my window takeoffs. I'll do my zone, walls, then windows. Here's my trick, because it never fails. Projects change. Usually people come back and say, hey, we changed the window, made it bigger, smaller. Okay, which window was it? So I always start on the front surface, and you'll see when I build my models, that's the process I take. I always go from right to left clockwise. So I'm going to start my takeoff. We have a 2636 window. So everybody knows what a 2636 window is in area, right? That's 8.75 square feet. 2.5 times 3.5 is 8 3/4 square feet. So we have two of those, 8.75. We could combine those, make that one window. I just have the habit of making those two windows, just my style. So yeah, whatever you prefer there works for you. When we get to the door here, we got a little different situation going on. We've got some Simpson, no, not Simpson doors, but probably a manufactured product, but may or may not be NFRC rated. So what I want to do is come in here and just grab the area of these using the area tool. Makes my life easier. So we got 7 square feet for each of those sidelights, and this transom is 8 square feet. So we'll I always put a little symbol in here, SL or sidelight. 7 square feet. Our door, let's go back to our floor plan. It's probably a 3068 door. So that 3068 door, we could measure that. Yeah, it's a 3068, 20 square feet for the door. We have another sidelight on the left, 7 square feet, and we have a transom. I use the code of a TR on the 8. Top is 8 square feet. So moving right along here, we got some more 2636 windows, 2 of those, 8.75, 8.75, and we got 2 3050 windows, 15 square feet apiece. So you do this long enough, you look at a window and you know exactly how many square feet are on that window. So left side, I like to zoom out a little bit to make sure that I'm not missing any windows that might be on an offset or inset somewhere. So in this case, looks like we only have 2 windows on the west, or on the left side. Those are 8 square feet apiece because they're 2 foot by 4 foot. Working our way to the back here, we've got, again, starting from this corner, working clockwise, we've got a 3050, 15 square feet. We got a door here. Tempered safety. Let me see if that's a half light, full light, solid door. The back of the house here, it looks like to me that's a solid door. So we're going to go with what the plan says. At some point, you know, the designer may come back and say, oh, we'll change that to a half light or something different, but it's in a bathroom, probably going to be a solid door. So 16.7 square feet. That's a 2668. I always go 2.5 times 6.67. It's going to give you your area there. We have a sliding glass door. I make that a window because it's a probably the same manufacturer as the other windows here. So 6068 is 40 square feet. I'm working my way around here. We got a 3060, 18 square feet. We have another slider at 40 square feet. Another window. I'm over here now, so if you're following along, 18 square feet. Zoom out, and one more slider, 40 square feet. Good. No questions so far. Good. Hopefully everybody's enjoying themselves, having a cup of coffee. Which reminds me, this is Code and Coffee, right? Our right-hand side windows, we got some 2640 windows. Those are 10 square feet apiece. Right on. Good. Well, that wraps up the windows. Couple things I like to point out is we have a vaulted ceiling in here. It might be good to add that vault because that vault is opaque surface to this outside. So let me go back to my section. Here's a little trick I do. I'm just going to run an area of this vault. Oops, clicked too quickly. 23 square feet. So I'm going to add 23 square feet to that back wall. So instead of 594, it's going to be 617 square feet. Now, that adds some volume to the house, right? We have a 9-foot plate, but you know, this area is vaulted here. So, you know, it does make a difference on the compliance documentation, your average ceiling height of the volume. So what we're going to do here is come back in and we could do all the geometry and figure this stuff out, or I can come in here and say, okay, I'm going to take an average length here. I'm going to hold my shift button down. I'm going to bring this in about half. So we'll call it about 17 feet, right? That's going to be about equivalent volume here. So 23 feet, 23 square feet times 17 feet gives me 391 cubic feet. I'm going to add that to the cubic footage of the house, right? So I'm going to take 1,638 square feet times 9. I'm going to add that together, and then I'm going to divide it by the square footage of the house. That's 1,638 square feet. It's going to give me an average ceiling height of 9.23871, blah, blah, blah. So I'm going to take 9.2 foot average ceiling height on that. We also have some knee walls associated with that space. So we've got this angled wall here, about 8 feet. We've got about 13 feet of straight wall. So little trick here. I like to do, you know, I want to get close, and I could probably just take that 23 square feet and it would be close. It's probably a little bit more than that because of the angle of that ceiling. So I'm going to come in here, and we know that clip ceiling is starts about 13 feet over, right? So I'm going to hold the shift button down, go over here, look at that, 13 feet. I'm going to do an area of this at my 13 feet, right? So 18 square feet for the flat surface, and the angled piece, I need to do a little bit of math. So we know it was 8 feet long, and it's about 1.5 foot high, that little piece of triangle. So 18 times 1.5 foot, we divide it by 2, right? Because it's a triangle. We get 13.5 square feet. Add that to our 18 gives us, no, let's see, 8, did I do that right? 18 plus gives us 24 square feet. So we have a knee wall of 18 square feet, and that's adjacent to an attic space. This is important. If you've missed those spaces, your model isn't truly correct. It's not taking into account those opaque surfaces from the conditioned space to those attic spaces. So we don't worry about this vault here because it's just a ceiling area. So now we've added our opaque surface to our elevation on the outside. We've added the opaque surface to the knee wall. So we have all our information. Let's take a look at our garage space now. So moving along, right along. We're about 24 minutes into our broadcast. Should have no problem getting this into EnergyPro. So I'm going to start with the front. Ceiling height's 9 feet flat, 28 feet on the front. is 252 square feet. I'm starting on my left side. 21 feet times 9 is 189. The back wall is, if you remember, that was 12 feet, right? So 12 times 9 is 108. Could have done that in my head. And we have another 28-foot dimension. It's 252 square feet. There are openings in this, and we need to model those as well. Standards say that if you have an attached garage, you also have to model that garage. So let's do that. We've got some sectional roll-up doors, 10 foot by 7.5 foot. That's easy, right? 75 square feet each. We've got 2 of those. On the left wall, we have 2 3040 windows, 12 square feet apiece. And you'll see how my notes are taking shape here. I'm a little sloppy when I'm taking my notes, but this helps me on the input when I'm inputting into EnergyPro. Make them as neat or as readable as you want. For me, that's enough. Sometimes I'll go in and actually record all this data in Bluebeam and save it just in case I have to update it later. We've got a door in the back, so no windows. That's a solid door, 17.8 square feet there, and windows on the right side. We got 2 3040 windows right here, 12. Now we need to account for this wall, this demising wall, or the wall separating the conditioned and the unconditioned enclosed spaces. So you know, you can do a linear dimension here. You don't need to separate these by orientation because there are no solar gains on these. So I get about 22 lineal feet. So 22 times 9 is 198 square feet. And that's adjacent to the garage. Now, when I input my interior surfaces, I always do them in the area of the conditioned space to the unconditioned space. So you'll see when I input this information. We also can't forget this door here, right? There's an opening there, a 3060 door, 20 square feet. So good. We won't worry about the mechanical stuff at this point because I've got some notes for that, but we can see we've got a water heater here. We've got an AC condenser out here. I got some notes that they're putting in a whole house fan, as well as I think that that air handler probably, or the furnace is probably located in the attic somewhere. There's probably a note up here. So if not, I'm pretty sure it will be. So these are, again, a preliminary set of plans. So let's jump over to EnergyPro and let's start entering this data here. We've got EnergyPro. So I'm going to give you guys the choice. I can enter this using the wizard, or I can enter this just from scratch. Any suggestions here? I like the wizard approach. It just makes things quicker for me, and I'll if you guys don't mind, I'll use that approach. So EnergyPro has a little wizard here, the residential wizard. It just makes things a little quicker. You know, I'm going to select my designer. I've gone through and entered a bunch of my designers. So Rob Keith, good friend of mine. So I'm going to label this code and coffee. There's 2 E's. Episode 1. I'm going to throw in the zip code here, because if I don't, it won't show up on the compliance documentation. So we know our front orientation. So there's a new construction, single family, front orientation. I like the orientation here because it sets up all my 4 cardinal orientations automatically. You could leave it at 0, then come back in and you're rotate the model at the building level tab to the desired orientation, but I like to input it here. The number of zones is 2. We have a conditioned zone and unconditioned zone. We're going to input both of those. I prefer to leave the bedroom number to either 0 or 1 because it prompts me to enter the number of bedrooms. It's important to enter the correct number of bedrooms because that's part of the calculation for your indoor air quality fan. I'm going to select the climate zone. This happens to be in Sonora. Sonora Ranger Station is our weather station we're taking. And move on to the next here. Some of you may not do it this way. Some of you may do it just manually, and that's great. I've got a assembly already built for the R38 ceiling, R18 below roof deck. Option B if you're using the prescriptive approach. So wood framing, insulation below roof deck, R18. The thickness of that top cord is 3.5 inches. R38 in the cavity, 2x4 framing, 24 inches on center. Okay, my walls. We saw from the plan those walls are R21. We're going to use the default R21 wall from EnergyPro here. That means it's a 2x6 wall, 16-inch on center framing, R21 cavity insulation. If you remember, our client doesn't want to do continuous insulation. So Chandra has a question. If you go through and add the assemblies, etc., to the library in advance, they will automatically show up in the wizard. Exactly. Yeah. If you add them to your default lookup tables, they'll already be there, and you can actually export these. So if you build a custom one and you click that export button, you can export it to your default library too, and it'll show up. Kind of cool feature there. We're going to stick with the prescriptive residential window here. The 0.32 U factor, 0.25 SHGC. When we get to our side lights and transoms, I've got another window feature there for you. So we'll tweak that one there. Slab on grade. It's not a heated slab, so we're not worried about it. Just move on here. Let's enter our envelope. So we know our wall height, average wall height was 9.2 feet high for the condition zone. That's always our first one that we enter. It's 1,638 square feet. It's new construction. Let's take a look at our roof slope. Switch to Bluebeam here. Looks like 6 and 12. Oops, didn't mean to do that. 6 and 12 roof pitch, and it looks like it's pretty consistent all facets of that roof. So good. We'll go back to EnergyPro. It's important to enter the correct pitch here. I've always, oh, yeah. Oh yeah, Lindsay's telling me I have a question. I think I already answered or addressed Chandra's question. So good. So roof slope 6 and 12. Slab on grade is 1,638 square feet. Our perimeter distance, which we did our takeoff there in Bluebeam, 165 lineal feet. We don't have any raised floor, so we just skip that, leave it as 0. Here's where I go into data input mode. So I'm going to do an over-the-shoulder view to kind of give you guys an example of how I do it. So here I am inputting the front wall. You can see my takeoff is in the same configuration as the plan. So I'm just going to go clockwise, starting with the front, 450 square feet. I'm going to enter my first window. That was 8.75 square feet, and my door, 20. So this kind of gives me a jump start into building my model. Left wall, 252 square feet. Window is 8 square feet. There were no doors on that. Rear wall is 617 square feet. My first window is 15 square feet, and we have a door, right? 16.7 square feet on the door. Right wall, let me switch back to EnergyPro. You can kind of see what I'm doing here. Right wall is 189 square feet, 10 square feet for my first window, no door. Roof area, same as my slab area, 1,638 square feet. We didn't go through and see if there were any skylights. Those are always one of those things that you go back and go, oops, I forgot the skylights. So I'm kind of scanning through here and seeing through. I don't see any indication of skylights, no tube lights, anything like that. So let's just assume for now that there's no skylights, and we're just going to pass on entering that. So now this wizard goes to my second zone. This is my garage zone. I'm not going to touch the wall height yet, because you're going to see when I set up my zones, I need to go in and change that. So floor area, 774 square feet. It's new. It also has a 6 and 12 pitch. Don't touch the floor number. It's all 1 at this point. Slab on grade, 774, same as our floor area. Perimeter length, 89 feet. Some of you may be modeling this at your desks while we're here, but that'd be kind of funny to see how that worked out. 252 square feet for my front wall. No glazing. We have my first door is 75 square feet. You can see if I weren't talking, I would input this stuff. Usually it takes a couple of minutes to input all this first-hand data. But, you know, we're kind of walking you through the process. 185 square feet of wall, 12 square feet of my first window, no door on the left, 108 square feet of wall, no window, 17.8 square feet of door. Right wall is 252 square feet, 12 square feet of window, no door. Roof is 774, no skylight. All right, good. This kind of gives me a starting of my HVAC system. I'm just going to select kind of what I know here. Both heating, cooling, ducted. It's in the attic. R8. We're good to go there. My hot water heater. I'm going to start with a standard tankless right here, just to for input sake. And I'm going to start with my standard distribution on that. So I'm going to run the performance calculation. I hit finish. It's always a good idea to save your project. File, code and coffee. I'm going to call it code and coffee 1 here, right? Couple things about this project that I know. There is no natural gas available up there, so that's something I want to set up right now. If you don't have the right heating source, you're going to get a plan check comment. Say natural gas isn't available in this area. Really not too much else. We don't have a crawl space, so we don't need to input anything on the residential tab. So our building or project level information is pretty much complete. Let's expand our tree here now. So you can see the wizard did a really nice job of organizing things. Our water heater's in. We might need to go back in and change that efficiency. Our HVAC system is in, the basics. I like to start at the zone level first. I always do my mechanical last. So I want to make sure my zone's dialed in. I like to name my zones myself. So call this one house. Here's something, we're at the zone level. Click on this dwelling units tab here. Here's where you're going to enter the number of bedrooms. This happens to be a 3-bedroom house. Because I'm using propane, the fossil fuel being propane throws an error in EnergyPro. I always change these to electric, and then I uncheck these appliances. There's no, for compliance standpoint, there's no reason to have the appliance calculation there. So we leave those off at this point. I don't need to touch anything else except this building story tab here. So you can see the software put in automatically my first ceiling height. This is my average ceiling height for the house zone, but the garage zone was just 9 feet. So here I'm going to change the floor to floor height as 10. It's got to be above the ceiling height. I'm also going to come in here and I'm going to name this house floor 1. I'm going to add a garage floor 1. And you'll see why here in a second. My garage floor 1 has a 9-foot plate. My elevation above grade, 8 inches. That's typical. Change this to 10 feet. Don't forget to come back and select this is your house zone. Otherwise, if you get them switched, it might not be reporting correctly. Go to our room tab. We ran this as one room. You could do a room by room calculation, which is, you know, kind of cool if you wanted to get some really accurate load calculations. But for this, we're doing the whole house as one zone, one room. If I could remember how to spell house, that would be great. We know our wall area is right, our assembly is right, our orientation is right, tilt is right. We can move on. Our first window is a 2636, 8.5 square feet. We're using this fenestration type. We know it's a 0.32 U factor, 0.25 SHEC. So here's a little trick I do. If I have multiple windows, I just copy it. Copy and then paste. I'm just clicking the right button. I like to put these in order, so I'll move it up on the tree. So everything needs to be in the same place in which I input it. That's me. That's how I do it. I like to do it that way. Keeps things organized. I'm going to add a window. This is going to be our side light. Our very first one. I like to label it side light. Okay, and it was 7 square feet. Now, it's probably not going to be the same window type as the other windows. Assuming that they have the door company make this, it may or may not have an NFRC value. So I'm going to come in here and I'm going to use a default. I'm going to use this double non-metal clear. I'm going to copy it. I'm going to call that side light. Okay, it's not site built. It's manufactured. It's not operable. We have dividers. It's a, let's call it a door. Okay, for all intents purposes, it's part of the door system. So good. Number of panes 2. It's an insulated unit. I'm going to hit OK, insert that there. I'm going to copy this and I'm going to paste it on the other side of the door. So, and then now I'm going to add another window and call that transom. T-R-A. Learn how to spell, Brian. That was 8 square feet. Oops, no overhang. I'm going to change the fenestration type to, it's basically the same. It's pretty much the same configuration. We'll do this. Call it there. I may have misspelled transom. Is there an E on transom? Anybody know? I don't know. It doesn't matter. Our next window is some more 2636 windows. So if you're following along in our plan, let me just jump back to Bluebeam. We're still on the front wall. We're on these windows above the kitchen sink. So I'll just move this right along, and I'm going to copy these original ones, paste. We got 2 of those, right? So we can just double check that we got the right ones. Yep, those are there. And our last 2 windows are going to be 305 on windows, so 15 square feet apiece. So copy that one, paste. So I don't like to type. If you guys can, you got that so far. So it copy and paste works well for me. Moving to the left side, area's fine, assembly's fine, orientation's fine. That all checks out. I like to check these when I'm inputting this information. That way I don't need to go back. I've already checked it. It's done. The input is correct. We have one other window. It's the same size window, so I'm going to do a copy paste. We're done with the left side. Rear wall, area is good, assembly's good, orientation's good. Let's move on to the windows. We got a 305 window. We have a 16.8 square foot door. We're going to enter another window. That's going to be our sliding glass door. That's 40 square feet. We have an 18 square foot window, and you can see I'm just clicking the right click button on the wall tab there, the wall assembly, and it just insert a new window. So I'm here, 18 square feet of window. Entering individual windows is nice because you can go back in and do a count just to make sure that you input them all right. So look at your takeoff sheet, count the number of openings, count the number of openings in your model, and move on. Sometimes, you know, if you're moving too quick, you forget to enter the area. That can happen from time to time. I'm just going to speed this up and copy that last one there. So we've got 15 square foot of window, a door. You can use the down arrow and just tab through these. 40, 18, 40 square feet, back to 18, back to 40, and we're on to our right wall. Gosh, our house is almost done here. 10 square feet of window, we've got 2 of those. I'm just going to right click, copy, right click, paste, boom, we're done with our walls, our windows, we're onto our roof. If we input this correctly in the wizard, only thing we need to do is change the orientation to the front of the house. So no big deal. I always like to hit save on a very regular basis. You never know when the system might crash. If we did our takeoff right on the wizard, then this should be good. Moving on to the garage zone. If you notice, I have not entered my interior surfaces yet. So very important. I finish my zones first. I make sure my zones are done. Then I go back and input my interior surfaces. So let's call this one garage, and make sure that we click the right building floor, building story. That's the garage floor that we created with a 9-foot plate. Click the dwelling tab. See, it has a number of bedrooms. Make that 0. There are no bedrooms out there. Change this fossil fuel to electric. Only do this for propane. If it's natural gas, there's no problem. It just, and I don't know why. I need to ask Martin why the software does that, or maybe one of our Energy Commission partners here might know. So looks like my zone is good, other than it's not conditioned space. It's a residential garage, right? So now we just identified that that's an unconditioned space. Changing my room to garage. I like to do that just so everything reports correctly on the CF1R. It just looks good. Now, if you remember, we input this using the wizard. Now, the wizard used our assembly for our conditioned space, and I don't like to do that. I've set up a what I call garage wall, and this is really to help the plan checker know that this is a garage and it's not part of the conditioned area. So when you see this on the opaque assemblies, it just says garage wall, and it says insulation none, R0, 2x4, 16-inch on center. So that means there's no insulation on that wall. You could put insulation, and it's going to have a minor impact on the overall TDV energy use. So just keep that in mind. Our door, these aren't wood doors. These are going to be garage doors. Select that. I'm going to copy and paste that. So we have 2 of these. Our left wall, we've got 2 windows. I'm going to change this wall assembly to my garage wall. Hopefully you guys are following along. I don't see any questions. You guys aren't giving me a bad time in the chat window. So I'm going to paste this window here. So now we've got our front wall done, our left wall done, our rear wall. Come in and change that to a garage wall. And you'll see why when we take a look at the compliance docs, the CF1R, changing this to a generic term like garage wall and garage ceiling is going to help the plan checker identify those in the opaque surface construction tables. So good. All right, and we need to copy this window. You could use a metal frame single pane window in this window openings here in the garage too. So we're not doing our below roof deck insulation on there. I've also set up a garage roof attic assembly. It has no below roof deck insulation, no ceiling insulation whatsoever. So I don't want to force my client into having to put insulation out in the garage. They can put it there if they want, but the standards don't say that you have to do that. So I don't make them do it. Orientation, again, we're going to change this to the front facing slabs. Good to go. All right, now we've got both of our zones done. Our model is built. We need to go back in and add our interior surfaces. So we have 2 interior surfaces to add. We got those knee walls. Remember, we did the knee wall from the vaulted ceiling. You know, we had those little triangle areas that we needed to include in there. So I'm going to go up the room level and I'm going to right click. I'm going to say add interior surface, right? That's going to be for a knee wall. I'm going to add another interior surface for the wall between the house and the garage. So let's input this information. My first one is going to be knee wall. I like to change these just to be a little more descriptive. So our knee wall area is 18 square feet. not a lot. I'm going to leave it at R21. We could put R13, right? If it was a 2x4 wall, the mandatory measures say a 2x4 wall. No, actually, R15, right? You have to do a R15 in that wall. The floor elevation is relative to the zone floor elevation. So we're not going to input that this thing is 9 feet above the floor. It's actually at 0.7 feet because that's our floor height. And we're going to say that's not adjacent to a zone, it's adjacent to a residential attic. Okay, so that's how you would input the knee wall, our interior surface, our demising wall between the conditioned area and the house is 189 square feet. Again, that is R21. It's a 2x6 wall. Floor elevation is 0.7, but that is going to be adjacent to another zone. It's adjacent to our garage zone. So there we go. We've just created both of our interior surfaces. We don't need to worry about our surface counts, because you know EnergyPro will throw you an error if you don't have if you don't have at least 6 surfaces in each zone. So luckily we had 4 walls in the garage, a roof and a slab, so there's 6 surfaces. We got our interior spaces connected, so our envelope is done. We shouldn't have any errors when we hit calculate. Let's go back and finish our mechanical here. We got about 10 minutes, no problem. We'll finish this up really quick here. I went with a standard tankless unit. Now our client is going to be using a 94 energy factor tankless. So I'm just going to come in here. I am going to copy that, and I'm going to change this to a 0.94 energy factor tankless water heater. I could go and import. Let's do that. Let's just import a gas water heater. Actually, that was the one that I imported here, this Noritz model, in a previous one. So energy factor, actually that's a 9.5 energy factor. Let's go with that one. I'm just going to select it. So it's 0 gallons, 120,000 BTUs per hour, 95 on a 0.95 energy factor. So we'll go there. We can tweak this later, but it's going to give us an idea. Distribution, I'm going to keep it standard. It means hot for a tankless water heater, first 5 feet, but we know we have to also go from insulate from the source to all the kitchen fixtures. So that's it on my water heating. Let's go to our HVAC system. It is a new system. Let's identify our system type. And I know from my clients' notes that this is a 92% AFUE gas furnace. They wanted a 60,000 BTU unit. It's 92% efficient. It's gas furnace, central, split DX. I'm good on the furnace side. This is going to be minimum efficiency. So 14 SEER, 11.7 EER. AC unit. We're assuming it's more than 45,000 BTUs. So let's say it's 48,000 BTUs. Typically the sensible is about 70% of the output. So 7 gives me about 33,600. I'm using these as placeholders. You can actually input the rated efficiencies here. This is already set up. This is the minimum. So I'm going to hit OK. Everything looks good there. Distribution, we already set that up. Ducted attic. You don't need to click this. That's for the E+A+A approach, but if you like to click it, great. It's a mandatory measure for duct leakage, so regardless if you click that or not, it's still going to happen. One thing we need to input, though, is they're going to be doing a whole house fan. Ventilation cooling. So they gave me some specs on a ventilation cooler. Believe it was a quiet cool product. We can take a look in the appliance efficiency database. I think I saved it here. If not, let's just do a real quick lookup. If you don't know where that is, MAEDBS. I just hit a Google search there. I do a quick search, and we're going to take a peek here. Let's find a unit. What I'm looking for is CFM, airflow, and my watts. So I'm not going to do a model number. I'm going to do appliance type first. Let's see if I can locate it on appliance type. Actually, let's just go straight to the brand. We got the brand, right? We're going to go down and select a quiet cool. Anybody see that here? It would help if I was in the right section, right? LMNO PQ, right? Sometimes I go to the let's see, Q. This is taking longer than I thought it would. Quiet cool. There we go. And I hit search. What I'm looking for is I got to meet the minimum airflow requirements based on the prescriptive approach in order to get that credit. So we have a 1,638 square foot house. We got to have at least 1.5 CFM per square foot. So I need something that's 2,457 cubic feet per minute or higher. So I'm going to go in here and as a placeholder, let's use this one, the QCES 2850, and see what that does. So that has an airflow rate of 2,850 CFM, and let's just round this to 178 watts. Okay, so we're going to 2850, and 178. How are we doing on time, Lindsay? We got 3 minutes. Perfect. We'll get this done here. We're not going to, let's see, we are going to do refrigerant charge. So let's go through here and hit save. And while this thing is calculating here, I want to go back to my over the shoulder view here. And any bets on whether this is going to comply or not? Anybody want to take a guess of what? I hear from my tech team saying that it's going to comply. So any other thoughts? You think it'll comply? So just through the magic of TV here, I'm going to go ahead and run the calculation through magic and see that it came up with a 6.1% savings. Yahoo! It complies. Let's take a quick look at the compliance documentation. We have 2 minutes left. We just want to double check here that we got everything right. So we've got our climate zone 12. We have a 1,638 square foot house. It's slab on grade, same as the conditioned floor area. Front orientation 143 degrees. We use the right compliance version standards here. Number of zones. There's one conditioned zone. Number of stories is 1. We got about almost 18% glazing percentage. Our compliance margin, we know that it complies here. Let's look at page 2. This is going to give us some of our special features. So we got a whole house fan. It would help if I brought you back here, right? A whole house fan. We got insulation below roof deck, indoor air quality, mechanical ventilation. We need to note that to the client, right? Minimum airflow, HERS verification on our cooling system, refrigerant charge, fan efficacy, watts per CFM, duct leakage. All right, so those are all of our HERS measures. We got a 3-bedroom house, so we know our indoor air quality fan calculation is going to work. 1 zone. We have number of ventilation cooling systems, 1. Good. It picked up our ventilation cooling whole house fan. You know, I already checked these. I checked these on my inputs, so I know these are right. If I did my calculation right, here we have our attics, our garage attic. We have our house attic. I didn't use a radiant barrier or cool roof. That's something that client didn't want, so we didn't model it. We could have, but we didn't in this case. All of our windows, we knew we did these right. Now we could go in and model overhangs and do all that. If we did that, our overhang table would show up on the CF1R. We didn't do it, so it didn't show up. Here's all of our opaque doors. Here's our opaque surface construction. You can see the construction name, garage wall, garage roof, attic. If I'm a plan checker, I'm going to ignore those because there are no cavity insulation values. Now I look at the house, attic, roof, house, R18 below roof deck, R38 at the ceiling, R21 exterior walls. Here's our interior wall, R21 interior walls. That's for the knee wall and the garage wall. Moving right along, I think we got everything else right. No QII. We've got a 0.94 energy factor water heater. We've got no additional pipe insulation. Furnace, 92 FU furnace, 11 SEER, 14 SEER, 11.7 ER. On the cooling side, it requires airflow and fan watt draw. We can see that here. Ducts are R6 sealed and tested in the attic. We're looking good so far. Here's our fan efficacy requirements. Fan watt draw. We get to the very end here. Indoor air quality. This is something I want to note. I'm going to tell my client, look, you need to put a note on the plans that say indoor air quality CFM needs to meet a minimum of 46 CFM. I'm using the default indoor air quality fan. That's an exhaust fan. So, and then here's my whole house fan input here. So look at that. My clock says 11:01. I'm sorry, I'm a minute over time. So that's it in a nutshell. Thank you so much for participating in our first episode. I'm going to bring us to our goodbye screen. We have a bit of information here for you, some of our additional tools at the Energy Code ACE website, the ACE tools, the ACE resources, fact sheets, trigger sheets, checklists, all sorts of things like that. You can contact us for more information about our program at AceTV@energycodeace.com. Please hit the like and subscribe button to our channel. Share it with your friends. And again, thank you very much. And we'll keep this broadcast live for a few more minutes, but for all intents and purposes, that's the end of our show. Stay tuned for more episodes coming real soon. So thank you very much. Let us know what you think of the show. So we'll be sending you an email, and hopefully it's positive. And I see Michelle, thank you. That was quick. Yeah, 1 hour. It's pretty amazing. You can model a simple house in under an hour, and I talked through the whole thing too. So anyways, so hopefully you guys have a wonderful afternoon. If you have any questions on the chat, hit me up. Otherwise, have a great day, and get another cup of coffee. Yahoo! All right. There is a time delay, so when I talk, there's about 15 seconds before I actually, you guys hear me. So it's something I have to get used to. So anyways, hit me up in the chat. Do we know what our viewer number was? Anybody take a look at that? So Chandra asks, interior service question. Does the R value input change the calculation anyway? It does, actually. Chandra, you could input the mandatory minimum insulation requirement, or you can input what, a higher value, and it does. Interesting fact, if you put insulation in the garage, in the walls, and in the ceiling, it has an impact on the overall TDB energy value. Very slightly, but it does. So you do run a few tests too, and you can kind of see the difference there. So yeah, such as insulation between floors, walls, things like that. Yep, absolutely. And if we had a two-story area, we would model that interior space, ceiling or floor, between a first floor conditioned and a second floor conditioned, or you have a second floor conditioned and a first floor unconditioned. That would be another interior space. So good. Well, I hope everybody enjoyed this. I had a blast. Nothing like putting a little pressure on me to do this in an hour. It was super fun. So I'm looking forward to our next episode. So I might take something on a little more challenge. If you guys have any ideas or would like to challenge me to something, I would love to do it. And just email me at remind me, it's let's see, what is our email address again? No, it's Ace. Yeah, it's AceTV, ACETV at energycodeace.com. So we'll send that. Yes, it's also in the description of the video. So Adrian says an E plus A plus A. Yes, I definitely want to do an E plus A plus A project soon. So, all right. So awesome, man. I'm so glad that everybody was able to tune in today. Look forward to more episodes. This is a blast. So good. All this after stuff, we might take these out and make them outtakes of the program. We might edit some of these things out, but it's good. It's good stuff. So look forward to an email from us with, just to give us some feedback. We just love to hear your feedback. So, and I'm sure Jill Marver, who is also listening, not only is my program manager, she is also the statewide lead, statewide codes and standards lead for all the training. So thank you, Jill, so much for giving me this opportunity. This is awesome. So, all right, I'm going to sign off now. So I haven't come up with a nifty sign off yet. I'll have to think about that. But how about this? Have a great day. All right, we're going to stop this now.